Okay, so today we are really diving deep into CLP. This AI model developed by OpenAI,
Right.
and this is not your average image recognition software.
Yeah.
This is some next level stuff.
It's really interesting how CLIP kind of flips the script on traditional image recognition.
Okay.
So, like, instead of needing thousands and thousands of labeled pictures,
Right.
it learns by connecting images with, get this, words.
You're saying, like, instead of showing a computer a picture of a dog and being like, dog? You're like, hey, this is a four-legged friend.
Yeah. Basically, CLIP learns by making connections between what it sees and how we describe it. It's not just a few pictures. We're talking about billions of images.
Wow.
Paired with text descriptions.
So it's learning from, like, a massive internet-scale scrapbook, basically.
Yeah, think of it like that.
Okay. So how does that help it outperform the systems that, were trained the traditional way?
Well, you see, this is where traditional models hit a wall. They're like specialists, They've memorized the answers for one specific test.
Okay.
But CLIP is learning broader concepts.
So it's not just recognizing dog, it understands the idea of dog.
Exactly. And this is what gives CLIP incredible edge in what we call zero-shot learning.
Zero-shot learning.
Yeah.
Okay. Break that down for me.
So imagine showing CLIP a picture it's never seen before.
Okay.
Something totally new.
Okay.
Now, a traditional model would be stumped,
Yeah.
right?
It's only trained on specific categories.
Exactly.
Yeah.
But CLIP can often still figure it out.
Really?
Yeah.
Wow.
For example, there's this thing called ImageNet.
Okay.
It's like the ultimate image recognition test, right? A huge benchmark. CLIP manages to achieve an accuracy of 76.2% on ImageNet.
Wow.
Without ever being specifically trained on that data set.
76.2%. That's wild, because, that ResNet 50 model,
Right.
that was trained on over 1 million labeled images.
A huge amount of data.
Yeah. And it was struggling to reach that same level.
Yeah.
I'm impressed. CLIP's zero-shot capabilities are honestly blowing my mind a little bit.
It's impressive stuff.
But how does it actually make these connections during that zero-shot moment?
It's not just matching pixels, right?
Yeah.
It's using language to understand the underlying concept.
So instead of just seeing a pattern of fur and eyes and a tail, it gets that this is a dog.
Right.
Like, it understands the essence of the image, not just the visual components.
And that ability, that connection of language and visual understanding, that's what allows it to excel in these zero-shot scenarios.
That's really interesting.
It's really cool.
So it's not just about the data. There's a technique at play here, right?
Yeah, it's called contrastive learning.
Contrastive learning. Okay, so what's so special about this contrastive learning?
Okay, imagine you're learning a new language.
Okay.
You might not get every word perfect at first, right?
Right.
But you start to understand when something's right or wrong based on the context.
Okay. Yeah.
So contrastive learning kind of works in a similar way.
So instead of memorizing, like, exact translations, it's more about grasping the relationship between words and ideas.
Yeah, you got it. Contrastive learning works by, comparing and contrasting.
Okay.
CLIP doesn't get bogged down trying to predict exact words. It's more about figuring out, like, does this image and this description, do they go together?
So it's swiping right or left on a dating app, but for images and descriptions. Match or no match.
That's a great way to put it. Yeah, and by training on billions of these matches,
Right.
CLIP builds up this incredible ability to understand, those links between the visual world and how we describe it with language.
That makes a lot of sense. But let's go back to zero-shot learning for a second.
Sure.
So CLIP aced ImageNet.
Right.
What about other visual tasks?
Right.
Is it a one-trick pony, or can it handle, like, different challenges?
That's what's so cool about CLIP. It can handle a whole range of visual tasks.
Okay, like what else can CLIP do?
Think about tasks that involve understanding both text and images.
Okay.
Take OCR, for example.
OCR.
Optical character recognition.
Okay.
CLIP's ability to link words and visuals makes it really good at deciphering text within images.
So it could read a street sign in a photo, even if it was partially hidden or at a weird angle?
Exactly. That's right.
Wow.
Or think about a task like geolocalization.
Okay.
Figuring out where a photo was taken based on the scene.
Right.
CLIP can do that too.
It can pinpoint a location just by looking at a picture?
Yeah.
That's wild.
Because it's learned from descriptions paired with images,
Right.
it can connect those visual cues, like the architectural styles, landscapes, with geographical locations.
So it's not just about identifying a building. It's about understanding that this building style is more common in, like, Paris than it is in Tokyo.
All right, exactly.
Mm-hmm.
CLIP is really grasping these nuanced relationships between what it's seeing and the language associated with it. And it's not just OCR or geolocalization.
Okay.
It can tackle fine-grained object recognition, too.
Fine-grained object recognition, what is that?
Think about, like, telling the difference between a golden retriever and a Labrador retriever.
Okay.
Or a Honda Civic versus a Honda Accord.
Okay. Yeah, those are pretty similar looking.
Yeah. It can be hard,
Yeah.
but CLIP can do it.
Really?
It can. Because it's not just looking at, like, superficial features. It's pulling on this vast knowledge base built from those image description pairs.
That's really interesting. It's like this visual multitasker.
Yeah, exactly.
It's adapting to all these different challenges.
And it's not just adaptable. It's also, like, incredibly robust.
Robust. Okay. What does robust mean in this context?
It basically means it can handle variations in data without getting thrown off. Remember we were talking about those traditional models and like overfitting?
Right, like becoming too specialized.
Exactly. CLIP is less susceptible to that because of its broader understanding. It can handle the messiness of the real world.
Where the lighting might be different or the angles might be weird.
Exactly, yeah. It's built for the real world.
Which is important for real-world applications.
Exactly. And you combine that with the zero-shot learning capabilities and the adaptability to different tasks.
Right.
Kind of a big deal.
It sounds like it. So CLIP is breaking all the rules, pushing the boundaries, but are there any limitations? It can't be perfect, right?
You're absolutely right. CLIP has its limitations. It's not a magic bullet.
Okay, so what are the caveats? Where does it stumble?
One thing that researchers are really trying to figure out is its reliance on a ton of data.
Okay.
And while that's a key ingredient to its success, it also brings up questions about data efficiency.
So it's a bit of a data hog.
Kind of, yeah. Which, that has implications for the resources needed to train these models and the potential environmental impact.
Right. Makes sense. It's a good reminder that even with these big advancements, we still need to be mindful of the resources that we're using. Are there other limitations we should be aware of?
Another challenge is how CLIP handles data that's truly out of left field.
Out of left field? Like what's...
Data that is vastly different from anything it encountered during training. For example, if CLIP has only ever seen images of printed digits, it might struggle to recognize handwritten ones.
Because it's so different from what it's used to.
Exactly. It can also be limited to the concepts present in its training data. It can recognize and understand a huge range of things. But it doesn't have the flexibility of, say, an image captioning model.
So it can't generate descriptions from scratch. It's limited by what it's been trained on.
Yeah, exactly.
So while CLIP is a huge leap forward in AI, there's still room for improvement.
Absolutely. That's the exciting part.
Yeah.
We're just scratching the surface of what's possible with models like this.
It's like we're on the brink of a whole new era of image recognition.
Exactly.
Yeah.
And as researchers continue to refine these models, address the limitations, and explore new things, who knows what we'll find?
It's like CLIP has opened this door and we're just starting to see what's inside.
And really get you thinking, right?
Yeah.
If CLIP can do all of this now, what will AI be able to do in 5-10 years?
It's kind of mind-blowing. Like, it really gets you thinking about the future of everything.
Yeah.
How we interact with technology, how we understand the world.
Imagine a world where AI can help us analyze medical images. With this crazy accuracy, maybe leading to earlier diagnoses, more effective treatments.
Right, or AI assistants that can actually understand what we're looking at.
Yeah.
Respond to our needs in a more intuitive way.
Exactly.
Personalized education. Like AI could tailor these learning experiences to individual students.
Right, based on how they learn best.
Exactly. And creative fields, too.
Oh, for sure.
Imagine, like, AI collaborating with artists and filmmakers.
It's going to be huge. It's going to be huge for those areas.
Pushing the boundaries of what's possible.
Yeah, totally. But it's important to approach these advancements carefully.
Right.
We really need to be thinking about the ethical implications.
Right. It's not just about what we can do, but what we should do.
Exactly. We have a responsibility to make sure these technologies are used to help everyone.
Well said. We've covered a lot of ground today. We talked about the technical details, the possibilities, the ethical questions.
It's been a really interesting look at CLIP and what it means for the future.
And for our listeners, I think this leaves us with a lot to think about. How might technologies like CLIP change our relationship with images?
Yeah.
The visual world around us?
It's an exciting time to be following AI.
It really is. CLIP is just the beginning.
Just the tip of the iceberg.
Thanks for joining us for this deep dive into the future of image recognition.